tricked you. In circuits, we usually don't think about the conductivity, we think about the resistance. That's what you're used to thinking about, the whole V equals IR. So let's see if we can get from the conductivity to the resistance. Let's draw it out here. Let's see. So I'm going to draw a nice big wire like that, and it has some cross-sectional area A. And let's see, it has some conductivity. The material has a conductivity sigma, and it has some length L, like that. We want to make current flow, so we've got to put a battery on here. So here is a battery, delta V between its positive terminal, its negative terminal, comes up here, touches that face. This one comes back here and touches that face. So we know what happens. That sets up an electric field, and it makes a current flow, and current is always from the positive side to the negative side. So instead of sigma, let's see what else we could say about this. So we know we have Ohm's law, J, the current density, current per unit area, equals sigma times the electric field. So let's see. So we know for a wire, for sort of this conducting wire, E actually is always delta V over L. Okay? In a parallel plate capacitor, you would have a nice uniform field like that. Well, it turns out inside of a metal wire like this, you also get a fairly uniform field, even if you start bending up, bending up the wire. So we can substitute that for E, and then let's see, we can also substitute I over A for the current density. Right? That's the definition of current density, equals sigma, and then E is the voltage difference over the length. And now we have the parts of this that we like when we're used to thinking of delta V, potentials and currents. We just rearrange this, and you get what? You get delta V that you like is equal to a bunch of stuff times I. It looks like L over sigma A. Okay? And that's actually the Gauss's law, or the Gauss law, the Ohm's law you're used to. V equals IR, V equals I, and this must be R. So this R for the wire is L over sigma A, is the resistance of the wire. And you can see what unit it must be in. It must be in volts per amp. But we have a special name for that, and that is the ohm. So ohm, even though he really didn't have a law, he really didn't have two laws, he did get something named after himself, and that is the unit of resistance, ohms, and it's written with an ohm mega, which is easy to remember.